Hello, welcome to Disaster Zone. Thank you for watching. We want to help you become more prepared for emergencies and disasters that can happen anywhere and at any time. I'm Kimberly Hill in for Eric Holdeman today. Computer simulations, emergency managers are now able to train for a potential real-life emergency using a computer simulation. It's emergency management training in the virtual world. We're here today talking with Howard Park from SimuDying. Thank you so much for being with us today.
Thank you for having me.
Tell me a little bit about your company. What does SimuDying do?
Our cognition platform helps smart people take advantage of the data and information that they have to make better decisions. Big data is here and readily available, but it's still difficult to use it to foresee into the future. Our software helps insight turn into foresight. We can view the outcomes and the decisions in a very safe environment. We work with some of the largest and the most interesting organizations in the world as they deal with their most complex problems. Our cognition platform enterprise software is used by clients in energy, healthcare, financial services, government, and NGOs to make strategic decisions, prepare for uncertainties, and manage growth.
So what exactly is simulation?
A simulation is a kind of model. A model is simply a representation of the real world. Let's think about maps. If I were to draw you a map of how to get to my house, I could just write it on a sheet of paper.
Right.
Or we can think about maps that are GPS enabled that are on your phone, or maybe the old-fashioned key maps. That's not the real world. The real world is filled with streets, cars, people, traffic lights, and the rules that govern that. The maps are a representation of that real world. So that's what a model is. A simulation is a subset of the model that allows you to try different what-if experiments. What would happen if I had more people on that road? What would happen if we changed the traffic signals? So a simulation is a safe environment where you can try different things. You can change the number of people and the objects. You can even change the rules. And it allows you to try different things that you can't do in the real world.
Could you do one with no traffic at all? Especially on the commute that I have? No, okay. Well, what kind of things can you simulate now?
Let me give you some examples of some of the stuff that we've done. For a European Commission, we helped them look into a disaster response in public places. How would people behave in a disaster in a train station? If there was a fire, a smoke, lots of smoke in the air, if there was an explosion or an active shooter, how would people respond to that environment? How quickly can they get out? And furthermore, can we improve that process by better communications, real-time communications with the people that are trying to get out, with limited mobility, with limited visibility, those kinds of things. And also, how can we coordinate efforts across the first responders, those kinds of things. So our software was used to simulate the people and the equipment and the smoke and all the different things and the associated technologies all working within a 3D environment that we built with our software. Another example, for medical facilities, we deployed an all-hazards evacuation training simulation. The model simulated patients and facilities, equipment and supplies, transportation, as well as caregivers who can be injured, who can get tired depending on how they work during an evacuate or shelter-in-place scenario. So patients can consume supplies, ambulances take time to get to their destination and come back, diesel gets consumed, time ticks away. So it's a great way to really engage with a wide range of people in situations like that, something they don't have a real chance to do in real life.
So it's a scenario, like a map, 3D simulated, where you can change like like maybe you have less gas or more patients. Or,
that's exactly right. And you can go back and rerun it. Right. That's how we learn. We learn by doing. And a simulation lets you restart. A simulation lets you fail. And a simulation lets you play back and learn from that process. We can rerun it. We can try different scenarios. We can say, what would happen if I did this? What would happen if you did that? What would happen if we did this together? That's what the power of simulation can bring for you.
How realistic are they? Can you really trust the simulation that it's being very realistic to a real life scenario?
That's a great question. Let's start with thinking about the kind of simulations that we use in everyday life. Think about the weather. We hear from the meteorologist what temperature we may have, whether it might rain or not, and we've learned to trust that. We use that to plan our day. We use that to plan our weekends, what we can do tomorrow, and those kinds of things. And we're used to doing that because we're seeing that we're used to seeing the results of that simulation, and we know what's behind it. Now let's think about what happens if you're not used to the simulation. So we emphasize the process, and we like to involve you in it. We don't like to build any of our models by taking the data, going away somewhere, and presenting a black box that just presents the answer to you. We involve you in the process. We help you see the work that we're doing. We have you define the business problem or the organizational problem that it covers. So we really like to involve the people in the process. And by doing that and putting that in the right context of the conversation, the training session, the package, the whole package, it helps people understand what's behind the simulation.
For it to work, what kind of factors do you have to have involved? What kind of parameters?
Sure. It helps to think about what you're trying to do. Let's go back to the map example. If I were trying to just make sure that you got to my house, a very simple drawing on a sheet of paper with the streets or where you would get off on the bus, that might suffice. That map may actually be incorrect. I may have the directions all wrong, north, up, down. I may even have some of the interim stops reversed. So the map is wrong, but it can still be useful. Now, let's pretend that we were trying to set a decision around whether we should change the traffic patterns or the traffic signals, or what might happen 10 years from now when we have more people move into a certain part of the city. That map that I drew for you would be inadequate for that. So we think about not only the model that we build, the simulation around it, but what we're trying to solve. So it's very important to understand the business problem at hand. And that's where we start. What is the fundamental question or problem that we're trying to solve? We don't start with the data. We don't start with the spreadsheet. We don't start with even the people that we know in the areas that we know. Another example, let's pretend we were trying to build a house, and I know HVAC, heating, ventilation, and air conditioning. You wouldn't start to build a house with the furnace and the ductwork. You would think about what the house is trying to do. Or if you knew gardening, you wouldn't start to build a house with laying out the flowers and the landscaping work. We would think about what the house is for, the terrain, what we're trying to do, what the boundaries of that would be. And that's the same way you should start a simulation. What are we trying to do? And then once you've defined the business problem, we can get into those factors. And so the functioning properly is defined by the process. We have to define what we mean by functioning properly. We also take an end-to-end perspective. What is the experience of the person seeing the model from start to end? And that works its way into not just the user interface, but even things like what do we call it? How do you access it? What is the physical space you enter into to experience that simulation?
Sounds fascinating. What about people? What people? People are not always predictable. How does that factor in?
People are always important to the process. They provide the information, the context. They provide access to the data, and they also help us understand how to make sense of the information that's presented to us. We don't start with the data, but again, we start with the description of the problem, and we validate the scope of that model. So when I'm talking to you or talking to folks that are involved in the process, and they present some information to me, I can make better sense of that and say, well, what you're saying makes sense to me, but does that represent everything that happens, or does that represent just 20% of what happens? So people are very important, and as we engage with them, because we've defined the business problem at hand, it helps us to understand what additional questions we need to ask and what additional data we need to get.
So I understand that you have used this kind of simulation in a regional port disaster simulation, and you learned a lot of valuable lessons. So I'm very excited to hear more about that. But we're going to take a break, and when we come back, we're going to show you more about the port disaster simulation and what was learned. Stay right here.
In the event of a catastrophe, you need to know what to do to make it through. By preparing now, you and your family will have a better chance of surviving when a catastrophe happens. Here are 3 tips to get you started. Have an emergency plan with meeting places and an out-of-area contact. Prepare a supply kit for your family and pets that includes what you need to survive for 7 to 10 days. And be prepared to help each other. Start now and take the first step to protect the ones you love. For more information, visit makeitthrough.org or find us on Facebook.
And we're back. We're back with Howard Park from SimuDying, and we wanted to talk about a simulation that you did for a regional port disaster. Tell us about that.
We were very honored to be involved in that very important effort. We had a great team and a lot of participants from the regional area, a few hundred people for the facilitation that we had. Regarding the simulation, we deployed our cloud-based solution using our proactive software. It allows us to model risk and see how decisions can mitigate that risk. It allowed us to understand the interdependencies across the different decisions. Our software uses something called system dynamics, which is a very powerful and proven methodology, a modeling algorithm that's very powerful in understanding the feedback and delays in a very complex system. Our simulation also had a lot of visual components, and the results were displayed on a series of maps, either at a given port or at the regional level, and that allowed a lot of folks to literally see the same picture. So from one port's decision, we see the direct impact on that port. So for example, after a disaster, a port may want to spend some capital funding to rebuild the cranes. And then it allows us to see the interdependencies. So a crane may want to spend money to fix their cranes, but the waterways may still be damaged. So we aren't able to bring in the heavy equipment to fix those cranes. And then we see the indirect impacts to the region. Because of my reduced business, the region has losses on taxes, and we get to see, well, because of that, not only do the state, local, and federal tax coffers come down, but there's an impact to the number of jobs that are associated in and around that port. And along the way, we also learned a lot of important things. So for example, the property tax levies may be decreased during that first year after a very serious event. That combined with my reduced business, and now I'm spending money to build up my port again, how long will my war chest last me? Those kinds of things. Another important element of our technology is that it's cloud-based. It allowed each port to be in its own separate room, making decisions. All these decisions were brought into the same world, and the simulation was able to calculate the system impact to the entire region.
So I'm hearing you say that a lot of it is about recovery after a disaster. It's like, how do we put the pieces back together again?
Right, right.
And what can happen, and what might some of the impacts be? What was the disaster? Can you talk about it?
Sure. We decided to work from a specific disaster, an earthquake, with the Seattle fault line, about a 6.5 magnitude earthquake, and then we work with seismologists and engineers and others who were able to guide us on a plausible earthquake and the consequences of that earthquake. So we looked at the number of buildings that were destroyed, we looked at the kind of waterway damage, we looked at the kind of damage to the rails and the road network that fed into that, and that provided us what we call the initial conditions for that model. So we started with the realistic view of what might happen. That also has an impact on the number of people that are working. It might be that your house isn't damaged, but you can't get to work because of the waterways. You may use a ferry to get to work. Or because of the number of buildings that are destroyed, you may be doing fine, but you may have to help out friends and neighbors. So you may not be available for 40 hours a week. We may only be able to count on you 2 days a week. Or the schools aren't open yet. So although you have the means to work and you want to work, you may have to take care of children. So all these different factors work into how quickly we can recover a port, and therefore the linkages between what a port does and how it impacts, and it also is impacted by the region.
When you create a simulation and then you can use it again, you can change the factors and actually go through the exercise again?
That's right. And that's where the learning comes from. We learn by doing things over and over again with slight variations. And just like a pilot learns by flying in a flight simulator, it's not that's a good analogy to use about our simulations. It allows the organization to run through different scenarios and learn from the mistakes. It makes those mistakes, learning from those mistakes, very cheap.
Or relatively so.
Yes,
right?
yes.
What kind of impacts did you learn from this particular? You were talking about you being able to see what the tax base would have to be changed. Anything else?
Yes. The ports already had some level of disaster planning in place. They had memorandums of understandings, or MOUs, already in place. But this really allowed people to test those out and get a sense of how well people understood those arrangements that were in place. How the planning and the relationships can help during the recovery efforts. And we know as a result of that there's a few things that are already happening. We know that the ports are revisiting those MOUs and thinking about how to make that more robust. We also know of at least one company who attended the session that is actually reviewing their business continuity plan and setting up a more robust plan.
How interesting. What other applications might you use a simulation for? You've got earthquake, and in the medical care facilities. What else might you use it for?
You know, it's really our imagination that limits what we can do. The mathematical tools, the algorithms that apply to this, and some of the visualization techniques have been around for quite a while. Our software makes it very accessible, and that visually meaningful format makes it easy to use. But it's really our imagination. So, for example, if we look at cities, in the 21st century, they have an array of challenges all brought together. There's finite natural resources, there's population dynamics, there's the ever-increasing expectations of our citizens, there's energy use, there's economic growth, and all these things coming into play. It's very difficult to see all the connections together into one place. So if we simulate the city and think it through all the dependencies and can put all that into a model, it allows us both the planning element, what might happen as a city grows, and also an operational element as well. Can we do a better job with trash pickup if we were to change out some of the rules around when we pick up the trash? But then what does that do with some of the unintended consequences? Does it get louder late at night? Those kinds of things. You can try, again, in the safety of a simulated world instead of doing that in the real world and failing in a very public way.
Sounds fascinating. What advice would you have for a company or jurisdiction looking to do something like this?
I would say think about the process. It's a natural feeling to start thinking about the data, about thinking through from a report that just came out. But think about the process. Think about defining the business problem. Set expectations, set a plan, and think about what's easy, and think about what's complex and what makes it complex. If you're new to this, start small. Start with a very small element. So, for example, in modeling out an entire city, instead of starting off with the whole city, start out with one element of it: water usage, trash pickup, public areas. Start with one aspect of it that can expand from that. Also, engage, not just with the data, but with the people. Get feedback. Have people involved in the process.
Can we learn real-life lessons from every simulation? Are there some things you can say, well, we really can't simulate that?
I think there's a lot that we can learn about the real world from our simulations. In fact, many of our simulations are used in a training context. A simulation allows you to fail safely, so it's a great way to learn for the real world. So we learn by doing. We learn by making mistakes, and it's not about just me learning. It's really about the organization learning. It's about you and I learning how the stuff that I know and the stuff that you know works together, and it allows us as an organization to get better at what we do. The world is so complex, whether you're looking at a regional recovery or a city or a very complex business, a global business. There is no possible way that one person can know everything there is to know about how it all fits together. So a simulation is a good way to bring in the knowledge and the data across the organization, put it into one place that allows us to try these different experiments and get us as an organization to be smart about what we're trying to do.
Can you give us a ballpark figure for what does it cost? What is the cost of some kind of simulation?
There's a comment that a client once said to me, and she said, simulations make failures cheap. How expensive is failure? Failures can be extremely valuable. If we can somehow peel away some of the negative consequences of failure, but retain that organizational memory, how valuable is that? How much is that worth? Whether you're learning to fly a plane, or deciding on how to best set up your warehouse, or making decisions in a very competitive world, or understanding the complexities in a regional recovery, things like how much money is it going to take? How long will something really take to play out? Years? Many, many years? What are the people elements? What are the different stakeholders, and what are their roles in making something like that happen? Simulation can help us understand those kinds of things in a very safe environment. It's no longer about, what I like to say is sometimes in a big decision like that, the person with the most amount of data and the loudest voice wins. And a simulation can really help mitigate against wrong decisions that come from that sort of bias. It allows all that to be put into one place where we can try safely in a non-confrontational way the different ideas that people have and have them see the same picture.
Is there anything else you'd like to add or tell us about SimuDying and the simulations?
First of all, thank you for having me. I've enjoyed the questions. I think we've only just started to scratch the surface in understanding what visual simulations can do in terms of what technology can bring to radical decision-making, or radically better decision-making, and the positive effects it can have in our future. We believe that all decisions of any consequence, especially in this ever-increasing complex world, should be simulated in order to save time and to lead to better decisions.
Sounds fascinating. Howard Park with SimuDying, thank you so much for being with us today.
Thank you for having me.
This brings us to the end of our show for today. Thanks for tuning in and learning more about what you and others can do to become better prepared for disasters. Remember, if you're going to be prepared, today is a good day to start. Have a great day.